Welcome again to another session of Everyday Mathematics. Now, here at Everyday Mathematics, we say we enjoy solving the harder problems, but also we see the beauty and appreciate it in the simpler problems. So today we are back to the year 2022 of the MIT Integration B finals. We move forward to problem 3, still on the topic of trigonometry. Our problem today is the integral of cosine 2022x times sine 10,050x over sine 50x times sine 10,251x over sine 51x, integrating from 0 to 2 pi. Now, before I head forward to the solution, a shout out to our subscribers. We really appreciate your support. We don't take your support for granted. For those of you who are here for the first time, we do encourage you to subscribe to our channel. We promise you'll never regret it. And for those of you who are here for the second, third, or fourth time, but haven't got an opportunity to subscribe, please do subscribe. We need that extra support. Now, this problem here is quite complicated. It's going to take some time to solve it. So for those of you who have a cup of tea that they need to bring closer, please go and get that cup of tea. So on to the solution to this problem. As you can see, this problem has these two fractions delineated. By that, I mean these two fractions are separated, and it's for a very specific reason. So let's take this fraction one at a time to try and simplify this expression of the integrand. So sine 10,050x is the same as, using Euler's expression, e to the power I 10,050x minus e to the power negative I 10,050x over 2i. Sine 50x is the same as I 50x minus e to the power negative I 50x over 2i. Such that sine of 10,050x over sine 50x is the same as e to the power I 10,050x minus negative I 10,050x over e to the power I 50x minus e to the power negative 50x. And so if we multiply e to the power I 10,050x both to the numerator and denominator, as we multiply across, obviously the second term in the numerator becomes 1, and then we do remain with e to the power I 10,050x in the denominator, but the first term becomes twice the 10,050x, which is 20,100x. And then if we multiply e to the power I50x, both the numerator and denominator, in the denominator, the e to the power negative I50x term multiplied by the e to the power I50x becomes 1, as shown here. And then the first term becomes e to the power I100x. So when we simplify this further by dividing this extra fraction, the next fraction here, we remove the extra 50x in the denominator, and we are left with e to the power I 10,000x. So going forward, since we have this expression where we have sine of 10,050x over sine of 50x being equal to e to the power I times 20,100x minus 1 over e to the power I 100x minus 1 times 1 over e to the power I 10,000x. We can suppose that u be equal to e to the power I100x, such that sine 10,050x over sine 50x equals to u to the power 201 minus 1 over u minus 1 times 1 over u to the power 100. So this first fraction can be simplified further. In fact, for those of you who are familiar with geometric progressions, you could see that this is just a summation of u being the common ratio and 1 being the initial term from 1 to 200. Another way is just by using long division. So let's try to just use long division. So inside the long division sign, we have u to the power 201 minus 1, and we divide it by u minus 1. So when you multiply u to the power 200 by u minus 1, you get u to the power 201 minus u to the power 200. Subtract that from u to the power 200 minus 1, you get u to the power 200 minus 1. And then if you multiply the divisor by u to the power 199, you get u to the power 200 minus u to the power 199. Subtract that from the previous expression, and so on. And you continue all the way until you get 1, and that means that the residual or the residue or the remainder is 0. So up here you see that the result of the division is this nice geometric progression with u being your common ratio and the initial value being 1. So taking that into consideration, we have u to the power 200 all the way to 1 divided by u to the power 100. That results into u to the power 100 plus u to the power 99 plus all the way to 1, because there is a u to the power 100 term in there, and when you divide u to the power 100 by u to the power 100, that results into 1. Then you continue the division until you get the last term, which is 1 here, resulting into u to the power minus 100 when you divide it by our divisor here. So we can group things. We have 100 with negative 100, 99 with negative 99, and then we pull 1 out here. And when we plug in place of u, e to the power I100x, this means that we essentially have 1 plus 2 cosine 100 times 100x plus cosine 99 times 100x all the way to cosine 1 times 100x. So this division that we saw here of sine 10,050x over sine 50x is equivalent to 1 plus 2 times the summation from k equals to 1 to 100 of cosine k times 100x. So I could express this a little bit differently. The sine 10,050x is the same as sine of into bracket 100 plus a half times 100x over sine of 100x over 2. This is obviously equivalent to 1 plus 2 times the summation of k is equals to 1 to 100 of cosine k is equals to 100x. Now we see 100x being our parameter here, but also we see 100 here coinciding with the 100 here. So a general expression would be that sine of n plus a half of y times y over sine of y over 2 is the same as 1 plus 2, k is equals to 1 to n of cosine ky. And this here is actually, it's a popular expression. It's called the Dirichlet Kernel. And so we can also use this expression here, this formula here now, to further simplify the second sign fraction that we have in the integrand. So the sign 10,251x over sine 51x can be expressed as sine of 100 plus a half times 102x over sine of 102x over 2. So this means that this is equivalent to 1 plus 2 times the summation from k is equals to 1 to k is equals to 100 of cosine k times 102x. So we have these two expressions that now has allowed us to eliminate the denominators in these two fractions. So we can multiply cosine 22x times the Dirichlet Kernel expression corresponding to this first fraction and that corresponding to the second fraction. So that means that that is equivalent to cosine 2022x into curly brackets 1 plus 2 times the summation of k is equals to 1 to 100 of cosine k times 100x, close the curly bracket, times the curly bracket 1 plus 2, we use a different index L here, is equals to 1 to 100 of cosine L times 102x, close the curly bracket. So this corresponds to this first fraction, and the second expression corresponds to the next fraction. So multiplying the terms inside the curly brackets, I would like to just color code the second expression so that this allows us to trace where each number goes. So when you open up those two the second brackets, first we're multiplying this initial bracket by the 1 here in blue, and then we multiply the initial term in the curly bracket with the next term there. So as you can see, we multiply this by 1, this just remains that. And then when we multiply this to the second term here in blue will be multiplied by 1 here, so maintaining that expression. And then the last term will be expressing the two summation signs. So this means that now we have this expression remaining as it is, 1 plus 2 summation from k is equals to 1 to 100 of cosine k 100. And then this second term remains plus 2 L is equals to 1 to 100 of cosine L times 102x. And then times this 2 times 2 results to 4. And then we nest these two summation signs. K is equals to 1 to 100 and L is equals to 1 to 100 of cosine k 100x times cosine L 102x, right? Then we have we can try to express this in terms of the sum of two cosines to eliminate the product and just lessen the complexity there. So as you can see, that's the same as the sum of the difference of the two angles and the sum of so the cosine of the difference plus the cosine of the sum of the two angles divided by 2 as shown here. So the 2 here propagates, it goes out and cancels with the 1, so we have 2 remaining there. And then when we multiply cosine 2022 through, so we have a cosine 2022x times 2 times cosine k 100x times cosine 2022, and then times 2, plus 2 cosine L 102x times cosine 2022x. And then now, because we've already now decomposed this into the sum, now we also multiply the 102L minus 100k x to cosine 2022x, and then the summation, but the addition part of 102L plus 100k x times cosine 2022x. Again, these two, 1, 2, 3, 4, we can express this product of the cosine functions into the summation expression. And we're going to do that as follows. So the initial term remains as it is because this is integratable. And then the second term here, we have 100kx and cosine 2022x. So again, cosine of the difference plus cosine of the sum of the triangles divided by 2. So how that changes, as you can see, we have cosine of let's try to reorganize a little bit. We have everything shown above here taken into consideration. So we have the first integral. Let's try to break this down into the first integral there, second integral in green, the third integral in purple, and the fourth integral in the yellow. So the first integral is simply the integral of cosine 2022x from 0 to 2 pi. That results into 1 over 2022 sine 22x from 0 to 2 pi. So when we substitute 2 pi here, sine of an integer multiple of pi is 0, minus sine of 0 is 0, so the result is 0. And then the second integral is twice the integral of this summation, k is equals to 1 to 100 of cosine kx, cosine 2022x from 0 to 2 pi. Again, as we can break it down into the two cosines, difference and summation, divided by 2. The 2 comes out, and that eliminates the constant we have there. And so we have cosine 100kx minus 2022x plus cosine 100kx plus 2022x. So because, as you can see, the 2022x is not an integer multiple of 100kx. So we have no fear that there is a value of k for which this term here becomes 0. So we can just quickly go ahead and do the integration, item-wise integration. So for the cosine, 100kx minus 2002x, the same as 1 over 100k minus 2002 sine 100kx minus 2022 from 0 to 2 pi, and the same for the 100kx plus 2022. We have the same method. Again, as we can see, when we substitute 2 pi here, any integer multiple of pi, the sign to that number of that number is 0. And when we also subtract 0, sign of 0 is 0. So all these expression amount to 0. The same thing happens for the third integral of that consisted the product of cosine L 102x and cosine 2022x. Again, the summation of these two cosines, cosine of 102lx minus 2022x plus cosine 102lx plus 2022x divided by 2. The half here goes out and reduces that constant to 1. But again, as you can see here, since 102 is not a factor of 1022, there is no fear that there is a value of L for which the value in the bracket here becomes 0. So for that, we'll just integrate that. Results into 1 over 102L minus 2022 times sine 102lx minus 2022x from 0 to 2 pi. And then here we have 1 over 102l plus 2022 sine 102lx plus 2022x from 0 to 2 pi. Again, integer multiple of pi results is 0, 0, 0. So that expression, the third integral, also amounts to 0. The interesting part now is our fourth integral, the one that had been enclosed in yellow. Because now we can try to express this product of cosine function into the summation. So for example, for here, we have the summation of the difference of these two angles and the sum of that two functions. So we have half into bracket cosine 102lx minus 100kx minus 2022 plus the cosine of 102lx minus 100kx plus 2022x plus again a half for the second product here of cosine of 102lx plus 100kx minus 2022 plus cosine of 102lx plus 100kx plus 2022x. So the halves go out, and then I reduce the constant 2 to 1. And then we have cosine of 102lx minus 100kx minus 2022x plus cosine of 102lx minus 100kx plus 2022x. And then here we have cosine plus cosine 102lx plus 100kx minus 2022x plus cosine of 102lx plus cos 100kx plus 22x. So we can now split that into 4 different integrals. Here we have the first integral in blue, the second integral in green, the third integral in purple, and the fourth integral in orange. All right. So let's attack those integrals one at a time. So the first integral, from 0 to 2 pi of summation of k is equal, from k is equals to 1 to 100 of L is equals to 1 to 100 of cosine 102lx minus 100kx minus 2022x. Now, there is a value of k and L when k is equals to 42 and L is equals to 61. This parameter or the phase function here goes to 0. So for that value, cosine is 1. So we have separated that out. Now for the remaining part, it is okay. There is no fear that this the argument into the cosine function will be at 0. So therefore, when we integrate that, the part for which the argument is 0, we get x. We integrate 1 from 0 to 2 pi, and the other part we have 102L minus 100k minus 2022 sine 102lx minus 100kx minus 202x. Again, from here we see any integer multiple of pi, sine of that is 0, and the sine of 0 is 0. So we're left with 2 pi as the result for the first integral in the fourth integral term. And then the second integral again, we have cosine of 102lx minus 100kx plus 2022x. When k is equals to 60 and L is equals to 39, that whatever is inside the bracket becomes 0. So we eliminate that, and we explicitly state that as being 1 plus the summand of the values that don't result into 0. Now, that now results into this integral, and then the same thing applies to whatever we also saw previously. So 1 over 102L minus 100k plus 2022 Sine 102 Lx minus 100kx plus 2022x. Again, integer multiple of pi. Sine of that number is 0, and sine of 0 is 0. So we're left with 2 pi as the residue there. And then for the third integral, the same thing happens. When k is equals to 9 and L is equals to 11, everything in the cosine function becomes 0. So for that, we explicitly set that value as being 1, and then continue summing the rest as 4. And so doing the same integration, we're left with the sine term that results to 0, and then the 1 term when integrated results to 2 pi, right? And then the fourth term, because we have explicitly as summation here, there is no value of k and L, since all the k and L's are positive, for which whatever is inside the cosine function is 0. So we'll just keep the summation as it is. And so when we integrate that, we get 1 over 102L plus 100k plus 2022 times sine of 102Lx plus 100kx plus 2022x. Again, integer multiple of pi, the sine of that is 0, and then sine of 0 is 0, so that results into 0. So now, that fourth integral now results into the summation of 2 pi plus 2 pi plus 2 pi plus 0, which is 6 pi. And our original integral there is definitely a summation of the first integral term, the second integral term, the third integral term, and the fourth integral term. The first integral term results in 0, the second integral term results in a 0 value, third also 0, and the fourth amounted to 6 pi. So the answer to this problem is 6 pi. Yeah, so it's been a pleasure really going through this very complicated problem. But there's a beauty in it. It's really beautiful. It takes your mind through a couple of things. But yeah, thank you so much for hanging out with us. It's been a really pleasure taking you through the solution. For those of you who have not subscribed to our channel, we do encourage you to subscribe. And when you subscribe, we walk with you through these very interesting adventures in solving these problems. Thank you.